This is a quick summarized video on the sine rule and how to use it. So if you want a more detailed video, there is another one that goes through more explanation on the formula and more examples. So the sine rule is a formula that we use to find missing angles and lengths in any type of triangle. So we're not restricted to right angle triangles like we are with SOHCAHTOA. So there are two forms of the sine rule, either taking the lengths divided by the sine of the angles or taking the sine of the angles divided by the lengths. Now, what you have here is three fractions being equal to each other. In reality, we'll only pick like two fractions, for example, these two, or maybe the A and the C, or maybe the B and the C. So you end up only picking two and then solving it as such. Now, what do they refer to? So the A, B's, and C in lowercase refer to the lengths. So, and A, B, and C in capitals refer to the angles. So notice how the sine is always next to the angles. So we can use, because the sine and because the length and the angles are in the formula itself, it means we can use the formula to either find missing angles or missing lengths. So why use the sine rule? When do you use it? So in another video I explained the cosine rule, but the idea is that you want to use it for non-right angle triangles. Now you can use the sine rule and cosine rule for right angle triangles, but we already have the SOHCAHTOA for the right angle triangle, so we stick to those. But SOHCAHTOA only works for right angle triangles, so we need an alternative for non-right angle triangles. So when do we use the sine rule? So more specifically for the sine rule, you can use it if you're given two angles and one side. So therefore you need to find another side. So that's one method. Or you have two sides and a non-included angle. So this is what I call a non-sandwich situation. So you want to find another angle in this case. So before we start with the rule, you need to know how to label the triangle. So you can pause the video and see and read through it. But the idea is that if you have a triangle, we label the angles with the capital letters and then the opposite length to your angle. So the opposite to A. So this length is going to be lowercase a. And so this length, which is opposite to the B, will be lowercase b, and hence lowercase c will be opposite the angle C. So that's how we label them, and it will be the same thing for cosine rule. So let's go through some worked examples. One example, I'm going to find the angle. One example, I'm going to find the length. So if I'm giving this triangle and it says find BC, which is the length. Now, in some questions, you might need to change the labeling. So maybe you want to shift it around. Maybe it's PQR instead of ABC. But the idea is that you always have, you always divide the length. You take the length divided by the sine of the angle, or sine of the angle divided by the length. So just remember that fact. But let's use the labeling that we have here. Once you're comfortable with it, you can try out any labeling in questions. So once we have that, if I have the formula, the sine formula, I can see that I need to find BC, which is A. So let's say I pick the sine A equals to B sine B equals to C sine C. Okay. So I have my A, I need to find the A, sorry. I have my angle A, I have the length B, and I have the angle B. So I can pick these two as my fractions. So I'll end up with A over sine A, B over sine B. The reverse also works if you use the sine A divided by A, sine B divided by B. But because we're trying to find the length, this is much easier to use. So what we're going to do, we're going to substitute the values. Sine A is just sine 38, B is 12, and the angle at B is 44, so sine B. Now what we're going to do is you can either cross multiply here, so you end up with BC times sine 44 equals to 12 times sine 38. That's one option, and then you divide by sine 44, so you end up with BC equals to 12 sine 38 divided by sine 44. Or you can use the fact that in order to cancel out the sine 38, you have to multiply by sine 38 on both sides. So this ends up canceling out, and you end up with sine 38 times this. So any method you'd want. So this is what you end up with. Once you solve it, you're going to end up with 10.6 centimeters. Be careful. Make sure you use brackets in your calculator to close in the angles. So that's how you'd find the length. What about the angle? So in this question, we need to find angle C. So let's finish our labeling here as well. So this is C, this is A, this is B. And using the formula, I can see that I could use the A, the sine A and A. And because I have the length C and I need to find the angle C, then I'm going to use the C fraction as well. So I have sine C over C, sine A over A. Because we need to find the angle, it's better to use this format, but again, the other reciprocal works. So I'm going to substitute my value. Sine C is what I need to find, divided by 12. Sine 88 divided by 20. Sine C is equal to this. Again, the way you do it is you can either cross multiply, so you end up with 20 sine C is equal to 12 sine 88. And then you have to divide by 20 on both sides, so you end up with sine C equals to 12 sine 88 divided by 20. Or you can say, well, to get rid of the 12, I'm going to multiply by 12 on both sides. So this gets rid of the 12, and I'm left with sine 88 times 12 over 20, which is what you get here. So any method you want. Once you have this, be careful that this right-hand side is not the angle. This is the sine of the angle. In order to get C, you have to get rid of sine, but sine is a function. In order to get rid of the sine, you have to take what we call the sine inverse. You've seen this already in trig ratios. So I'm going to take the sine inverse of this whole thing on the right-hand side. So make sure that the whole thing is in your brackets, and that's going to be equal to 36.8. So it's a number that actually makes sense. As additional practice, you can try and maybe, if you want to, find B, and maybe using just to double check that you've done the correct formula and stuff. So that's sometimes good practice to have. Make sure all the angles add up to 180. So hopefully the examples were clear. It's just a matter of knowing which fraction to use, and then just being able to use the fraction properly and simplify properly. Remember, if you need to find the angle, you have to take the sine inverse of that angle.